Alright, so this LeetCode question is called minimum depth of binary tree. It says given a binary tree, find its minimum depth. The minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. Note, a leaf is a node with no children. Alright, so given this binary tree, if we go down the right side, the depth is 3, but if we go down the left side, the depth is 2. So the minimum depth of this is 2.
Alright, so the key to solving this problem is to use breadth first search. If you don't know what I mean, there are a couple ways you can traverse a tree. One way is to use depth first. So what that means is you start at the top and you go as deep as possible. We go somewhere like there, and then here, and then there, and check the other side going as deep as possible. Or we can use breadth first search, which is what I'm going to do in this solution. With breadth first search, it starts at the top and then checks each child in this direction instead. Alright, so how do we actually do breadth first search? We'll do it using a queue. And if you don't know what a queue is just a data structure in which the first element added will be the first one removed. So let's say we added these in this order. 1 came first, then 2, and 3, and then 4. Which one is going to be the first one removed? 1. Which one's the next one? 2. Next 3, and then 4. I also have a video explaining more in detail what a queue is and how to implement it, and I'll link that down below. Alright, so we're going to need to keep track of a couple things. One being the current depth, of course, since that's what we're trying to figure out. And I'll explain nodes in a bit. Alright, so I'll go over quickly exactly what we're going to do, and then I'll slow it down a little bit in the second run through. So what you do is you add the first node to the queue, and you check to see if it has any children. Remember, what we're looking for is a leaf node, and a leaf node is a node that has no children. Once we find a leaf node, we can stop and just return the depth. Alright, so again, we check to see if it has children. It does, so we need to add the children to the queue. 15 and 20. Alright, so now that we're done with that node, we need to get rid of it, and we need to add 1 to our depth. Because what we're saying is that our tree has at least a depth of 1. Next, you move to the children. So the number 15, you do the same thing. Does 15 have children? Yes, it does, so you add them. So the number 2 is added because it's its only child. And since we're done with that, we get rid of it and move on to the next child. The next child was the number 20. Again, we check to see if it's a leaf node. It's not, so we add its children. And now that we're done with it, we take it out of the queue. Alright, so now that we're done another level of the queue, we need to add another one to the depth. Now let's repeat. Look at the first thing that's in the queue. Is it a leaf node? In this case it is. So what we're going to do is we're going to add 1 more to the depth and return that. So what we're saying is that this tree has a minimum depth of 3. Alright, so what's this mysterious nodes variable I mentioned down here? All it is a mechanism we're going to use to keep track of how many of the nodes in a level we've already taken account of. What I mean is this. After we added 17, we say, okay, well, this level only has 1 node. Once we've removed 1 node, we know that we can add 1 to our depth because we're done with that level. For instance, let's say we do 17. Is it a leaf node? No. So we add its children. We remove it. Add 1 to the depth. So at this point, we'd have a depth of 1. And now that we've done that 1 loop, we know that our nodes remaining is 0. Move to the next level. How many nodes do we have now in the queue? We have 2. So now we know we have to do that logic for 2 nodes. So now when we get to the number 15, we say, is it a leaf node? No, so we remove it and add its children. So that's just the node 2. And at this point, we've only done 1 node, in this level. So we'll just decrease nodes by 1, meaning we know we only have to do one more node before we get to the next level. All right, so now we're on the number 20. Is it a leaf node? No, we add its children, 19 and 24. We can remove it. And now that we've removed it, we know there are 0 nodes left on this level. So we can get rid of this. And once we know there are no more nodes left on that level, we can add 1 to the depth. Let's just finish that off. Now we're on this level. How many nodes are in the queue? There are 3. So now we know we need to do that logic possibly 3 times unless we find a leaf node first. So we start at the number 2. Is this a leaf node? Yes. So now we add 1 to our depth and we're done. We don't actually have to do anything to the nodes variable this time because we found our answer. All right, so let's get to the code. I've shortened the example a little bit on the left in order to save time. All right, so what LeetCode has given us is a function called minDepth, which accepts the root, and the root is just the root of the binary tree. All right, so the first thing we have to do is we have to check whether that root is null. Because if nothing was given to us, then it has no depth. So the depth would be 0. All right, so the next thing we have to do is we have to create the queue we talked about. We can just do this with an array. So we'll say let queue equal an array. That'll look like this. Okay, now we have to push the root into our queue. So queue dot push root. Next, we have to instantiate our depth variable, and we'll instantiate it at 0 because we haven't done anything yet. All right, now we need an outer while loop. This outer while loop helps us traverse down the tree. Then we need an inner while loop. The inner while loop helps us to go across a level of a tree from left to right. But in order for us to keep track of how many nodes there are, we need to have our number of nodes variable. We'll make that equal to the number of nodes in our queue. Now we can make our while loop that says while number of nodes is greater than 0. Misspelled nodes. All right, so now we need to grab the node or nodes that are in our queue. So we'll say let current node equal queue.shift. In JavaScript, shift just returns and gains access to the first item in an array, which is how we're emulating a queue. Because remember, in a queue, the first item that was added is the first one removed. All right, so now that we have access to that, we can show that like this. It's going to be out here. Now we're going to check if that item, which is the node 17, has any children. If it has no children, we've gotten to a leaf node, in which case we can just return the depth at that point. So we'll say if current node.left equals null. Remember the current node right now is the node 17. And current node.right equals null. So here we're checking if it has no children. If it has no children, then we could just increment the depth and return that number. But that's not the case in our example right now. The node 17 has 2 children. So we need to add those children. So we'll say if current node.left doesn't equal null, meaning it has a left child. What do we need to do? We'll add that child to the queue. That would look like this. Its left child is 15, so we're adding that to the queue. We also have to check if it has the right child, and if it does, add that to the queue. So if current node.right doesn't equal null, Then we'll add its right child. That would look like this. Its right child is 26, so that's in the queue. I forgot to add our number of nodes. So right now our number of nodes in that first level is 1. It was just the node 17. So now that we've checked the children of the node 17, we can just decrement our number of nodes. All right, so our number of nodes in that level is now 0. So now that our number of nodes is 0, it means we can start our outer while loop over again. And it also means we can add 1 to the depth because we've successfully gone through all of the nodes in this row. All right, so depth plus plus. At this point, this is the finalized version of the code. So if you want to run it now, it should work. But let me just walk you through the rest of this example. So we're on the outer while loop, line 21, line 22. It says let number of nodes, I missed the S. Let number of nodes equal the length of the queue. The length of the queue right now is 2. So now we enter the inner while loop. We're going to access the first node. All right, so we're on line 27. It asks if the node 15 has any children. No, it doesn't. So now what we could do, if you look at lines 28 and 29, is we add 1 to the depth, which is right here. And now we'll just return that immediately. And that maps to our example. Our minimum depth is 2. All right, let's run the code, see how we did. Looks good. Let's submit. All right, so our solution was faster than about 81% of other JavaScript submissions. As usual, the code and written explanation are linked down below. If you like the video, give it a like and subscribe to the channel. It helps out a lot. See you next time.